Okay, now we're going to solve three problems on geometric series. Problems are problem 194, 124, 125, and 126. You may find these problems on pages 107 and 108 on your textbook. So starting with problem 124, we read: suppose you make 30 annual investment in a fund that pays 5% compounded annually. If your first deposit is 7,500 and each successive deposit is 5% greater than the preceding deposit, how much will be in the fund immediately after the 30th deposit? So from the information in the problem, the first annuity is for $7,500. The interest that the compounds in the account is 5%. Each payment is 5% larger than the previous one, and there are 30 payments. The question is, what's the future value? Now, if you notice, both I and J have the same value, and remember that you have to be careful because there are two sets of formulas. One when I is equal to J, and another one when I and J are not the same. So obviously in this case we have to use the formula when I equals to J, and the formula that we need to use is F, the future value is A1 times N times 1 plus I to the N minus 1, and this formula only is valid when I is equal to J. So when we plug in the values, we have 7,500 times 30 times 1.05 to the 29. The value of that is the future value is $926,130 and 51 cents. Next problem is problem 125, and we read: in problem 124, how much will be in the fund immediately after the 30th deposit if the fund pays 6% compounded annually and each successive deposit is 6% greater than the preceding deposit? So from the information in the problem, we notice that the first annuity is for 7,500. The first annuity, the interest rate is 6%, and also the increment of the payments are 6%, so therefore we need to be careful and again check which formula we're using. N is equal to 30 again, so the expression that we have now is F, the future value is 7,500 times 30 times 1.06 to the 29, and that answer is F is equal to now 1,219,137 and 28 cents. Now we proceed to solve problem 126. On Juan's 26th birthday, he invested 7,500 in a retirement account. Each year thereafter, he deposited 8% more than the previous deposit. The account paid annual compound interest of 5%. How much was in the account immediately after his 35th deposit? So from the statement of the problem, we realize that the first annuity is 7,500. The interest rate of the account is 5%. The increment of the payment is 8% with respect to the previous deposit, and that implies a geometric series, and the number of periods is 35. Now, in this example, I is different from J, and now we need to use a different formula. So we need to be aware of that. The formula, we still need to find a future value in this problem, so we would need to write 1.05 to the 35 minus 1.08 to the 35 all that divided by 0.5 0.05 minus 0.08, all that times 7,500. The result after we do these computations is that there will be 2,317,332.23 at the end of the 35 years.